Thank you. So, welcome from my side to the conference. My name is Sascha Dittmann. I'm a data solution architect at Microsoft, and for the next 30 minutes, I would like to show you two things. First of all, give you a brief introduction to Azure Databricks, and secondly, show you two use cases or some scenarios derived from two real-world projects and how the services connect together, and show you two demos of those services and how to connect them. So in a nutshell, before I start, how many of you have seen Azure Databricks before? So pretty much half of you. Good. So the Azure Databricks is the pure Databricks platform running on our Azure platform. It's a first-party service which gives you one major advantage. One of it is that the whole supporting and everything runs on our systems. It's a first-party service, so the billing, everything runs on our platform, but still with the pure Databricks experience. When you look at the landscape, the Azure landscape, and the big data offerings, you see four major services. And I would like to compare them so you've got a relation what Azure Databricks is and where it belongs to. So first of all, of course, like many cloud platforms, storage is external. So you've got two storage systems. One is Azure Storage, classical object store called blob storage. And the second one is Azure Data Lake Store, which is really designed for big data workloads. So Azure Data Lake Store, for example, runs internally for over 8 years, and we published it as a service, I think, around about 1 or 2 years ago, so everyone can use it. On top of that, you can provision pretty much any other service. First of all, of course, marketplace offerings, pure standard Hadoop workload, like a Cloudera, Hortonworks, MapR, and so on clusters, and of course, also classical Spark workloads. But you're still on an infrastructure as a service level. Up next are two managed services. One is HD Insight, which is purely the Hortonworks Hadoop distribution, and of course, for that, also integrating with Spark as a workload. But you still have much control over it. You lose a little bit of control due to the management, but there are still VMs, you can still connect to them, and you can still work with them. Compared to Azure Databricks, it's a totally different story. The system will generate still the virtual machines under the hood into your subscription, but you are not able to access them anymore. Everything else will be completely managed by the Azure Databricks platform, which has the major advantage of security. And last but not least, which will not be part of today, but just for completeness, our kind of big data job as a service approach, which means Azure Data Lake Analytics, where you can just schedule your job there and you will be charged on a job level, but not on a per minute level like the other three offerings. Coming back to Azure Databricks, what is the idea behind it? When you look at the Azure landscape, you've got several services. Things like Kafka based on HD Insight, things like our Event Hubs, which is a fully managed event queue, and other services. Which means on the left-hand side, you've got all the data sources, IoT, storage, and so on. And in the middle, you've got the Azure Databricks platform. Looking at its core, it's still Spark, but surrounded by an enterprise security level. So Azure Active Directory is a key component throughout the whole stack of services, which means that you log in with your credentials and it's single sign-on up to the file level in the end. You've got the Databricks I/O advantages, so a second cache, special series, and so on, where you can read the data way faster than the standard Spark level. Databricks Serverless, which is purely Docker-based, and on top of that, or surrounded by that, I would say, the Databricks platform, which you already saw in the keynote this morning. And last but not least, the outcome of that, again, the model can be hosted on Kubernetes, for example, on Azure Kubernetes services. You've got the BI tools, could it be Power BI, Tableau, or something completely self-made. You can export the model, the reports to your own stuff, and push the data, of course, to a data warehouse. Could it be an Azure SQL data warehouse, Snowflake, whatever. So far to the very brief introduction behind the scenes. But what I would like to do is more demo-focused session for now. That's why I want to move to my machine and go to the Azure portal. So if you haven't seen the Azure portal before, it's kind of a metro-ish, I would call it, interface where you can add your services on your dashboards. And on the top left corner, you've got a plus sign where you can create a new service. If you click on that, it opens kind of a search dialog. You see the popular interfaces. You can search to the analytics space, and there is Azure Databricks. Another option, if I have no idea where the service will be categorized, I can just type in Databricks up there, and it will come up as well. Then you get the service description, brief idea what's behind the service, and click Create. After that, those white things are called blades. You get a plate for the Azure Databricks service. When you look at the information you have to type in, this is pretty lean. You just have to give that workspace you want to create a name. Pick a subscription, which is nothing else than a cost center in the end, and create an Azure Resource Group. An Azure Resource Group is there to combine services to logical units. And on top of those logical units, you can again apply access rights and so on. So once again, give that thing a name. And then pick a location. Currently, there are 52 regions across the world where the service could be spun up. I'll pick West Europe just as an example, and pick one of the pricing tiers. Standard is classical Databricks platform, and if you want to have what I mentioned, the access rights down to the service level, you have to pick premium to have that role-based access control enabled as well. After clicking Create, I did that already because that'll take 5 to 10 minutes. The few things will be generated for you. First of all, a resource group behind the scenes. That resource group contains all your resources, which will be automatically provisioned by the Azure Databricks platform. And this is a managed resource group, which means that you can add resources, but you can't change or access the existing ones. You can see them, but that's about it. Everything else will be done by the Azure Databricks service. And you get such a nice UI, which honestly just contains the pure minimum settings on the left-hand side. So an overview tab, what happens to that service, adding access control, who's able to delete and change the service, and so on. And that's pretty much it. Then you get a few links on the lower part, which just are links to the Databricks documentation, and a huge launch button. I opened that already. Let me close that for a second. And you click Launch. And what happens, once again, single sign-on throughout the whole platform. Azure Active Directory picks up my credentials and logs me in directly to the Databricks platform. The next thing I have to do is creating a cluster. To be honest, creating just a workspace costs you pretty much nothing. For one reason, most of the resources which have been generated are free of charge, like networking and all that things. And there's one storage account generated. And like I said, nearly nothing means there's some demo data which will be put into the storage account, and that costs some tiny value if you don't delete it. But once again, spinning up, and now comes the costly part, is a new cluster. Giving the cluster again a name. And then decide if I want to have high concurrency or a standard cluster. Standard is fine for me. And picking a Databricks version, which means the different Databricks versions, and you see those come into pairs, more or less. One is GPU enabled, one is not. So picking the version of the Python runtime, and then, of course, the virtual machines which will be generated for that cluster. You can pick a various list of machines, and of course, the grayed out ones are only GPU enabled. And since I picked a non-GPU version, I can not select it at here. And there are two nice features again. One is autoscaling. Start with a tiny cluster, kind of a base level of worker nodes, but automatically scale up, and as a cost level, more or less, put up the maximum workers nodes. And for me as a developer, there's also a nice feature, especially I always forget to turn down, to terminate my cluster. That's why I love auto-termination. And just type in some time, and when the services run idle for 120 minutes or 60 or whatever I type in there, it will automatically terminate the cluster for me, which saves money in the end. Like I said, you're currently not able to access the machines directly, which means that Spark configuration, again, needs to be in either a central place or on a notebook level. Same for environment variables or scripts which run on the startup time of the cluster. After that, Databricks, the Azure Databricks platform, goes into the managed resource group and really spins up the machines for you. In this case, 1 head node and 4 worker nodes. So far for getting started. And like I said, I want to show you 2 use cases which are pulled from our real-world projects and a little bit leaner to make them available in 30 minutes. So one is wind farms. So we had a customer who had wind farms offshore and pulling down the data, and you can see the demo, by the way, in our booth as well, pull down the data to so-called, I would call it a field gateway in an IoT perspective. It's called SCADA, and that's where the data has been pulled. And the question was, how can we build up such a system with only fully managed services? And that's what we came up with. First of all, we initiated something called Azure Event Hub, which is pretty much like Apache Kafka, a fully managed service to really just queuing data on a highly scale into the system. On top of that, we built a classical Lambda architecture, so a batch layer which pulls down the data from the Event Hub and stores it on a blob store. And of course, calculates different computed views and pushes it to a serving layer, in that case, an Azure SQL Data Warehouse. For those of you who have no idea what an Azure SQL Data Warehouse is, it's a multi-parallel processing SQL server. So think of, I don't know, 10 or 60 SQL server running in parallel and acting as one machine. So that's more or less a SQL Server data warehouse. And after that, you can visualize it, for example, with Power BI or any other tool. And last but not least, I also have a hot pass. Once again, the Databricks platform to pull the stream from the Event Hub with a structured streaming, generating a real-time view, and I can push it either, for example, to a Power BI or what you will see in our booth, to a web page to visualize that. Once again, going into the details. So to look into the system, I created a folder for my wind farms, and in the end, 3 major notebooks. Looking at the speed layer, what we built in for every of our services, either directly built in out of the box, or you can add that as an external library, is the driver for event hubs. So setting some standard configurations, so I can do that on a notebook level as well, and then just defining my event hub credentials. Pulling that in as well, and initiating my stream. When you look at the JSON which comes back from my turbines, I just created a standard schema on top of that to be able to work with it. And last but not least, pulled the data in, converted my body property of the event hub to a string because that's binary based, applied my schema and flattened the whole JSON to a table. And last but not least, then I'm able to just initiate the stream, which will just pull the data from the streaming environment. What happens on the Azure side? When I move there, looking at my event hub that takes, I don't know, 20 seconds to set up, we'll start pulling the data, and there I've got some producers which is generating the data in the meantime. On top of that, of course, I see my data now coming in. Let me cancel that for a second. And use the query which I put into an in-memory table a few seconds ago before I started my session. And on top of that, of course, I can execute, for example, SQL commands. And the nice thing about the Databricks platform in general is I also have some visuals which I can pull in to visualize my data. On the batch level, I did pretty much the same thing. So I've got two basic ideas to pull the data into my data warehouse. The first thing is just a stream like you saw that before. And what I did is I just pushed it on the blob storage level as Parquet files. And when I move to my environment from the warehouse, I can just create an external table. Once again, this is just a pure SQL server, could be on premises. In that case, it's just hosted in the cloud. And I'm more or less pulling it or pointing it to the blob store where my Parquet files are. Creating that external table, and just with a second statement, pull that data into the system. That would be one option. And the second option is not even leaving the Databricks platform, because we built in that SQL Data Warehouse driver into the system. I have to specify a storage account, which is just for generating files in the background, so some temp store, and then just do a standard JDBC connector. On top of that, you pick the SQL Data Warehouse formatter, add the URL for the SQL store and the storage, and that's about it. Then I'm able to, for example, access my orders. Executing those two table commands. And after that, doing a count. One is 6 million, the other one should be around about 24 million rows. And then I can, for example, execute just on with a SQL query my data, which is running on the 24 million rows and doing an aggregate. Pretty much the same story. But that's just working from the Databricks platform. What's also nice is I can push the results of my query back to the data warehouse, again with the write command. And if you look closer to the status messages, you see that it's, of course, extracting the data frame, then generating Parquet files in the background in my temp store, and asking the data warehouse pretty much the same thing I did on the SQL side, to pull it back in. Because all, in my case, 10 SQL servers run in parallel and pull the Parquet files in parallel into their system. So, and after that, I can just use them on the back end as well. Going to my next use case. So this was a classical IoT scenario with a Lambda architecture. Once again, I picked an IoT scenario because it's currently more or less hyped to a heating system, house automation. And the challenge with that heating system is it's not very concentrating on, I don't know, Germany or Europe where the data is produced. It can be spread across the whole world where the data will be produced and put to the system. That's why I picked Azure Cosmos DB. Azure Cosmos DB is a purely NoSQL document or JSON store where you could put data in. And the nice thing is you can spread it across the world. You can pull up more or less in every region of our data centers a copy of that system, and all those databases will automatically replicate the data to each other. So if you look at the same architecture again, the data will be directly published into the HTTPS endpoint of my Cosmos DB environment. Then I've got the batch layer where I can compute directly on the database on the Cosmos DB and add further collections to have more or less computed views on my data. Same for streaming. There's a capability of Azure Cosmos DB which gives you a stream of changes happening in the global environment of that large scale or massive scale database, which is a change feed. And I can pull that change feed, once again, with structured streaming into my system and generate, for example, a real-time view. I want to restructure that architecture a little bit, because the central element is that Cosmos DB. The master data as well as the computed batch views are just collections into that one distributed database. And the systems directly ingest the data into the master data set. Then Azure Databricks more or less pulls the data out of the master data set and generates new ones for the computed batch collections. And then I can directly attach, for example, Power BI or anything else, to that system. Same for live data. I can pull the data from the change feed to the structured streaming capabilities of Databricks, and again, generate a real-time view. So once again, how does that look like in code? By the way, this one is not running. I have no idea where I am. So, once again, I just added Cosmos DB as a driver. And the nice thing is I can add the preferred regions. So the list of regions which will be used in order for reading. Since my Databricks cluster is currently in West Europe, all the data will be primarily read from West Europe. Looking at the same thing from the Azure side, this is my Azure Cosmos DB blade. As you can see, I set up my database acting in 3 regions, one in the US, one in Europe, and one in Asia, and push data in every of those regions to the system, which you can pretty much see when you look at the metrics. So in every 3 regions, data ingest is happening. So once again, executing that connection string, creating a view out of it, and then I can, for example, start counting, so around about 139,000 objects, and for example, show the first 20 of it. Looking at the batch layer, what I did is pretty much the same thing. Some import statements, then setting up the connection, creating a view, just showing the view that it's working, and then use another connection string to write the data. I set up for an upsert, did a bulk import in the end, and then write the statement up there back to another collection. To get that scheduled, I used the job scheduler, which you can just run in there. Let me run that thing now. And is more or less executing that notebook in the background for me on a timely basis, for example. From a speed layer perspective, pretty much the same story, having some import scripts, defining a connection. In this case, I decided to have the change feed feature on. And then, for example, generating a read stream, and again, pulling it just to an in-memory table to be able to show that. And again, just querying the live data, what's in that temp table, and executing my queries on top of it. Like, yeah, give me the first 20, or just an area chart. So pretty much the same story. One thing I missed out yet was the visualization. I just picked 2 examples. One is from the wind farms demo, just live querying my Azure Data Warehouse, and I can interact with the data, switching other farms, and it's again querying just that data. The second one is from my heating system, where I can see the different sensors running, selecting lines, more or less filtering live on my data. And last but not least, and that's the demo you will see downstairs at our booth, is pretty much the same story, just a live view of the wind farm data. That's it from my side. I'm happy to answer questions, and if you have further questions, just join me at the booth.
So I'm not sure whether you're going to have the answer. It's less on the Microsoft side, more on the Databricks side. So during the keynote speech today, we also were presented with Databricks Delta, I think, and ML Flow. Mm-hmm. So is that on the Azure Databricks available?
Yes, it is. And that was the notebook I skipped. That was Delta. So you can just, let me pull it here. You can just create a Delta table and just use it.
Flow as well?
Pardon?
Flow as well? The ML Flow as well, because that's just the... the Delta.
Right.
side.
It's coming. What you currently have to do to be able to use ML Flow, that's what I did in my cluster as well. I said in the beginning, there's a managed resource group. You can't change the existing resources, but you can add your own ones. What you have to do currently is spinning up your own Linux machine, putting ML Flow on it, and just hook it into the system, and then it's running. So that's currently the workaround, but it works.
So from a cost perspective, would you choose Azure HD Insight or Databricks?
From a pure cost perspective, it really depends on the workload in the end. It's a little bit cheaper to choose purely HD Insight, and we've got the capabilities of not only doing Spark. On the other hand, using the Azure Databricks platform is way more convenient. So from a cost perspective, yes, HD Insight would be cheaper. Pure VM costs.
Hi. About the service provisioning, there's a different we know how AG Insight is charged is by the time the cluster is on. How does it apply to Databricks?
When you create a cluster, you've been charged by every of those virtual machines and at a minute level, same for standard VMs, but there is something in here called Databricks units. And that's the, I would say, upsell on top of every machine. There is a standard charge related on which regions you're in and so on. And for every virtual machine from the one I selected, there's 3/4 of that charge added to every minute of the machine. So that's why the question with the HD Insight compared to the Azure Databricks, standard machines, standard virtual machines are cheaper.
A question about the cluster. How long does it take to deploy the cluster?
It really depends. It's definitely faster to provision a Databricks cluster, because the whole Ambari thing and so on takes most of the time of an HD Insight cluster. It really depends. It took me around about 3 to 5 minutes to spin up my 5-node cluster. It's a wild guess. It's quick. Depends. Compared to HD Insight, where it takes the same cluster takes around about 20 minutes.
All right, if there are no further questions, thanks very much, Sascha, and the
Welcome.
next session will begin in a half hour.